Hello friends, let us begin with another session on buoyancy and flotation. In this session, I am going to cover some numericals asked in the previous game. So first problem is the point of intersection of a buoyant force and the body center line is A option is metacenter, B option is center of gravity, C centroid and D center of pressure. Obviously the option is metacenter A. Answer is A here. Then second one is the center of gravity of the volume of liquid is displaced by an inverse body is called. Option A is center of pressure, option B is metacenter, option C is center of buoyancy, and option D is centroid. The right answer is center of buoyancy. Right answer is center of buoyancy. If the following is true, based on the following data for a floating body, the distance between the center of buoyancy and the center of gravity is 6 meters, and the volume of the body submerged in a fluid is 9 meter cube. The moment of inertia of a plane of body at fluid surface is about the y-axis is 36 meter raised to 4. So option A is body is stable equilibrium. Option B is body is neutral equilibrium. Body is unstable equilibrium, and none of these. So the answer is here. So here GM or mg or mg equal to I upon V. I upon V. Now I is here 36 and volume is 9. Volume is 9 here. So volume is 9 here, and the center of buoyancy and the distance between the center of buoyancy and center of gravity is 6. So that is minus 6. That is BG. BG is 6. So this is 6. So 36 upon 9 minus 6 is equal to. So it is minus 2. So it is minus 2 meter. So hence the sign is negative here. So the body is unstable equilibrium. So option C is correct option. Option C is correct option. A stone weighs 392.4 Newton in air and 196.2 Newton in water. The volume of the stone is, the problem 4.1 is, the volume of the stone is, the options are A is 0.02 meter cube, B is 0.04 meter cube, option C is 0.066 meter cube, and 0.08 meter cube. Using the same data, what is the specific gravity in the problem? Number 1, that is options are 1, option B is 2, option C is 3, and option D is 4. So let us begin with the first problem, that is, let us find the volume of the stone is. So this is 392.4 Newton in air and 196.2 Newton in water. So take the difference here. So the difference is here. The difference is 196.2 Newton. 196.2 Newton. Okay. And volume of the stone is. So the weight in the air upon G, or the stone density. Find out the stone density. So volume of the water displaced. So volume of the water displaced of the water displaced is equal to 196.2 divided by 10 raised to 3 into 9.81 into 9.81. That becomes 0.02 meter cube. That is 0.02 meter cube. So the option A is right option. Option A is right option here. Then problem 4.2. That is, what is the specific gravity in the problem number 1? What is specific gravity in the problem number 1? So here, weight in the air is 392.4 upon 9.81. Weight in the air. Weight in the air. Weight in the air is 392.4 upon 9.81. That is equal to 40 kg. That is equal to 40 kg. That is equal to 40 kg. Now find out the stone density. Stone density is equal to 40. That is mass in the air upon volume. Mass in the air, that is 40. Mass in the air upon volume, that is 0.02. That is equal to 0.02. So that is the stone density is 2000 kg per meter cube. This is the stone density. And the specific gravity. Gravity is equal to 2000 mass density of the stone upon mass density of the water. That is equal to 2. That is equal to 2. So option G is the right option. Option G is the right option. Here. Okay. So in first case, option A is right option, and in second case, option G is the right option. Here. Okay. Another problem number 5. A uniform body 3 meter long, 2 meter wide, and 1 meter deep float in water. If the depth of immersion is 0.8 meter, then find out the weight of the body. The options are 47088 Newton, option B is 41099 Newton, option C is 30318 Newton, and option D is 28871 Newton. So we have to find out the correct option. So first of all, find out the volume. Find out the volume. Volume of the body is 3 into 2 into 1. So it is 3 into 2 into 1. So that is equal to 6 meter cube. 6 meter cube. This is the volume. Now weight of water displaced. Weight of water displaced. Weight of water displaced is equal to V into 0.8. Basic gravity is 0.8 here. Depth of immersion is 0.8 here. That is into G into rho W. That is equal to 6 into 0.8 into G is 9.81 into 10,000 1000, that is 10 raised to 3. That is equal to 47088 Newton. So 47088 Newton. The option A is right option here. Option A is right option here. Okay. Now find out the metacentric height. So first of all, let us find out the moment of inertia. That is equal to BD cube upon 12. That is equal to BD cube upon 12. That is 3 into 2 cube upon 12. 3 into 2 cube upon 12. That is 2 meter to the power 4. 2 meter to the power 4. Then 6 volume displaced. So 6 point into 0.8, that is 4.8 volume displaced. So 4.8 meter cube. Okay. Then Bg is equal to I upon V. So Bg is equal to Ag minus Gv. That is equal to 1 upon 2 minus 0.8 upon 2. 0.8 minus 2. That is equal to 0.1 meter. That is equal to 0.1 meter. And metacentric height is metacentric height is equal to 2 upon 4.8 I upon V. Okay, that is I upon 1. Moment, yes, correct. So that is 0.317 meter. 0.317 meter. 0.317 meter. So option A is right option. Here option A is right option. Okay. Now problem number 6. A ship of 5,000 tons has second moment of area on waterline section about its force is 1.5 into 10 raised to 4 m raised to 4 and the center of buoyancy is 2.5 meter below the center of gravity. So the metacentric height options are number 1 2 meter, B is 1.5 meter, C is 1 meter and D is 0.5 meter. So let us find out first the volume of water displaced. Volume of water displaced. Volume of water displaced, which is equal to 5,000 into 10 raised to 3 upon 10 raised to 3. That is volume of water mass density. That is 5,000 meter cube. That is 5,000 meter cube. Now Bm is equal to, as usual, Bm is equal to I upon Vp. Bm is equal to I upon Vp. So moment of inertia is given here 1.5 into 10 raised to 4 into 10 raised to 4 upon volume displaced is 5,000. It is 5,000. So that is equal to 3 meter. That is equal to 3 meter. That is equal to Bm is 3 meter and buoyancy of center is 2.5. So center of buoyancy is buoyancy located at 2.5 meter below G. So therefore 3 Bm minus Bg, that is 2.5. That is 0.5 meter. That is 0.5 meter. So option D is correct option. Option D is correct option here. 0.5 meter. Okay. So this is the solution to this problem. If the radius of gyration is 3.5 meter, then the time period of oscillation are 7.93 second, 8.93 second, 9.93 second and 10.93 second. Use the formula for this simple harmonic motion. SHM, simple harmonic motion. That is, this formula is T is equal to time period is equal to 2 pi upon 2 pi into K square, that is radius of gyration, upon Gh. upon GH. Use this formula. Then 3 point, that is equal to 2 pi into radius of gyration is given here 3.5 square, 3.5 square upon 9.81 into H. What is H here? H is 0.5. So H is 0.5. So T is equal to, here T is equal to 9.93 second. 9.93 second. So option C is correct option. Option C is correct option. Okay. So this is the solution to the link problem number 6. Radius of gyration of a ship is 10 meter and metacentric height is 1 meter. The time period of oscillation of a ship is option A is 10 seconds, option B is 20 seconds, option C is 30 seconds, and option D is 40 seconds. So let us begin with the solution. So here, find out the simple harmonic motion formula here as usual. So T is equal to 2 pi into under root k square upon gh. Okay. So this is k is 10 meter. 2 pi into 10 square upon 9.81 into h. H is here 1 meter. So 1 meter. So that is 20 seconds. The answer is 20 seconds here. So option B is correct option. 20 seconds here. So option B is correct option. 20 seconds is the right answer here. Then we will go for another problem. The moment of inertia of a ship of weight is 30,000 kilonewton is 10,000 meter to the power 4 at waterline. Its center of buoyancy is 15 meter below the center of gravity. If oscillation time period is 10 seconds, radius of gyration. What is the radius of gyration? In short, we have to find out the radius of gyration. So, as usual, we will go by usual procedure. That is, here GM is equal to, or Mg is equal to, GM is equal to I upon V. GM is equal to I upon V. So, minus Bg. This is our universal formula that we have already discussed. So, volume displaced is equal to weight of the ship upon weight of the water. So what is the weight of the ship? It is given here. Weight of the ship is 30,000 kilonewton. Isn't it? Yes, 30,000 kilonewton. So 30,000 upon weight of the water. 30,000 kilonewton into 10 raised to 3 upon 1,000 into 9.81 So that is 3058 3058.1 meter cube. And GM is 10,000. It is I upon V. So 10,000 upon 3058.1. So I upon V is equal to this. So that is I upon V is 1.5 meter. 1.5 meter. I upon V minus Bg. So I upon V is 10,000 upon 3058.1 minus Bg. Bg is 1.5. Bg is 1.5. So that is equal to 1.77. That is equal to 1.77 meter. That is equal to 1.77 meter. So T is equal to 2 pi into K square upon GH. So here we want to find out the K here. So everything is given here. So T is here. Yes, 10 second. T is 10 second is given here. So substitute 10 second. 10 second is equal to 2 pi into under root K square upon 9.81 into H. H is 1.77. H is 1.77. That is this value. Now find out K. So K is equal to 6.63 meter. 6.63 meter. Following this, we will get K is equal to 6.63 meter. So this way, option C is correct. So option C is correct. Option C is. Let us begin with more problem. That is, in an iceberg, 15% of the volume projects above the sea surface. If the specific weight of the sea water is 10.5 kilonewton per meter square and the specific weight of the iceberg is in kilonewton per meter square. So you will have to find out the specific weight of the iceberg in kilonewton per meter square. That is 12.52, 8.93, 9.81, 7.83. So first of all, now let us draw the diagram here. Then some part is floating here of the iceberg and some part is floating here above part and some part is below the water surface. So let us say this is 0.85 V. So this portion is 0.85 V and this is 0.15 V. 0.15 V. This is ice block. So the total volume of ice is V. Total volume. V is total volume. Is total volume. And projected above is 0.15 V. Projected above. And projected below is 0.85 V. So FB is equal to, so FBD ice cube, FB is equal to rho SW into volume displaced into G. Okay, and FB ice for ice is rho ice into volume of ice into G. For equilibrium, W is equal to FB. So that is rho W or rho SW. We have written here rho SW into redisplaced into G. This must be equal to the FB for ice. FB for ice, FB water and FB ice. Okay, so V ice, oh sorry, rho ice into V displaced ice into G, that is rho ice into G into V is equal to rho water into G, rho water into G into V for water. So that is rho ice G into G is equal to 10.5 into 0.85 V, that is equal to 8.93 kilonewton per meter square. Per meter square. Per kilonewton per meter square. So 8.93, so that is 8.93 kilonewton per meter square. So this is the right answer. So option B is right answer. So this way we have solved the problem number 7, 8 and 9. I think it is 9. Sir, this is 9. Okay. This is last problem. For a body completely submerged in a fluid, center of gravity G and the center of buoyancy B are known. The body is considered to be stable equilibrium if B does not coincide with the center of mass of the displaced fluid, G coincides with the center of mass of the displaced fluid, B lies below G and B lies above G. Now this is the body floating in water. G, this G here, this is B here, okay, and tilted position, so theta, B shift from this point B1 and this is G here, G here, and this is GM sin theta. Okay. So restoring couple is equal to W into GM sin theta. For completely submerged body will be the stable equilibrium when CG for stable equilibrium for completely submerged body, for completely submerged body, the CG lies below the center of buoyancy. I am talking about the submerged body, not floating body. Below the center of buoyancy. It will be equilibrium. It will be unstable equilibrium. Sorry, unstable equilibrium when Cg lies above center of buoyancy, above center of buoyancy, and when Cg or Cg coincides with center of buoyancy, it is neutral equilibrium. It is neutral equilibrium. So in this case, here B lies over C. So in this case, B lies above G. So option D is correct option. So option D is correct option. Okay. So this completes the today's problem session on buoyancy and flotation. In next class, we'll solve some more problem on buoyancy and flotation, and then we'll switch over to another chapter. Thank you. Those who have not subscribed my channel, please subscribe it. In the interest of more knowledge on the subject of civil engineering and law subjects. Thank you.